Hi everyone, in this lesson we're talking about composite functions, and we're also going to be looking at the domain of a composite function. All right, so first of all we have, our vocabulary here. We have a composite function defined. F of g of x means that g of x is going to be input into the f function. It's read f of g. That's f of g of x means g of x would be input into the f function. So this could be a little tricky for students. They have a hard time with it. The easiest way I have for explaining is if I want f of g, I know that that means that I'm going to put the g function into the f function. So what I like to do is I'll take that f function and I'll just put a box wherever there's an x in the f function. And so you can see there's an x right here for the f function, so I'm just going to put a box there. So let's do that. So that means I'm going to have, and it's going to be to the fourth power. So inside that box is going to go the g function. That's going to go inside the box. That's wherever we have an x in the function. So we're going to end up with the g function, which is 2x plus 3 to the fourth power. Okay, as it shows you there. The other way you can think about it is you can think about the main function as a machine, and that inside function is being input into the machine. So we put that function in, and when we produce it, we're going to get 2x plus 3 to the fourth. Same idea. Different ways of thinking about it, same idea. So let's look at some examples here. So we have some notation that says that our f function is 2x plus 1, and our g function is going to be 3 minus 4x. So we're going to do f of g of x and g of f of x. So first of all, let's rewrite this. I like to write that, like I said, as f of g of x. So the f function in this case is like the leader. So I'm going to look at the f function, and I'm going to put a box wherever I have an x. Right, so if you look at that f function, I have an x right here. That's where I put the box. And then you just have to put the g function in wherever you have a box. So our g function is 3 minus 4x. And now we'll just go ahead and simplify that. So 2 times 3 is 6, minus 8x plus 1. That's going to give us negative 8x plus 7. All right, let's take a look at the next one. We want g of f of x, so we're going to rewrite it. I mean, I like to do it this way. You don't have to rewrite it, but it just helps me see very clearly that this time the g is the leader and the f function is going to be put inside. So for the g function, I'm going to put a box wherever I have an x. So I'm going to put a box there this time. So let's write that out. So we have 3 minus 4, and then replace the x with a box. And then inside the box is going to go the f function, because the f function is being input into the g machine. This is the f function. All right, and then we'll just go ahead and distribute. I would say now, for example 2, I just want you to notice that instead of x here, we have values. It just changes things a little. I think what we want to do is find it in terms of x, and then we'll just input, -1 in or 0 in, depending on what is being asked. All right, so let's go ahead and figure out, first of all, we want g of f of x. I'm going to do it this way for letter A. And so that means I'm going to put a box wherever I have x in the g function. So I'm going to need a box here and a box here. All right, so we're going to have a box squared plus another box. And then I'm going to input the f function wherever I have a box. So it's going to be 6x minus 5 and 6x minus 5. All right, so I don't even really need to distribute that at this point. I know that I want to replace the x with a -1. So let's do that now. So I have g of f of -1. And now I'm going to replace x with a -1. So wherever we have an x, so here we have an x, right? This time we're saying wherever there's an x, put a -1. And we get 110. All right, let's try the next one. Now this one says we want f of x. So we're taking the function and putting it back into itself. That's a little confusing. So first of all, we know that f is our lead function. So we're going to put a box wherever we have x in our f of x function. So let's do that. And then inside the box is going to be the f function. Again, we're using the f function to be input into the box. So that's going to be 6x minus 5. The process doesn't change. It looks a little funny, but it doesn't change. All right, so now at this point, we're being asked to input 0 in. So let's do that next. So in this function, I'm going to replace x with 0. All right, now moving on to the domain of a composite function. There's 3 steps to follow when we're finding the domain of a composite function. We want to find the domain of the inside function, find the domain of the composite function, and then we're going to find the intersection of those 2 domains. In other words, we're going to see where those domains overlap. So I have an example here. It says find the domain of f of g of x if f of x is the square root of x and g of x is x plus 1. All right, well, first of all, what is f of g of x? Now, g of x is the inside function, right? If we're writing f of g of x, we're writing that. G of x is the inside function. And we want to know, are there any values that we could put into g of x that would cause a problem? Well, it doesn't look like it. We can put negative values in, we could put 0 in, we could put positive values in. So the domain of the inside function is all real numbers. Right now, if we take the g function and we input it into the f function, so we have, here's our box, right? That's where x is in the f function. And we put that in there. We're going to put x plus 1. Right? So f of g of x is the square root of x plus 1. Is there anything that we could put into that function that could cause a problem? Well, we know that we have a problem whenever we have a negative number under the radical. So we know what's under the radical has to be greater than or equal to 0. You could have the square root of 0, that's okay. You could have the square root of a positive number, that's fine. But you can't have a negative under the radical, that means we have an imaginary number. If we solve this for x, in other words, if we subtract 1 from both sides, we find out that the domain of the composite function is x is greater than or equal to -1. So the domain of this whole function then, where do those functions overlap? The domain of g of x, let's just make a number line, all right? This is the domain of g of x. That's all real numbers. And the domain of the composite function is x is greater than or equal to -1. So if I were to just do that like right next to it here, this is the domain of the composite function. Here's -1. It's got to be greater than or equal to -1. Well, where do they overlap? They overlap right here. So the domain of the composite function is x is greater than or equal to -1. Now, that is a little tricky. This isn't something that, you're just going to instantly get. We've got to do some practice, and hopefully you'll feel better as we do those. For example 4, we're going to find the domain of f of g of x given f and g. All right, so step 1, we want to find the domain of the inside function. So we want to know what is the domain of the inside function, which in this case is g of x. All right, so what we want to do is we want to look at the function and decide if there are any values that we could put in there that could cause a problem. So we could put negative in, that would be okay. We could put 0 in, we could put positive values in. Everything would be okay. So our domain is the set of all real numbers. So we can write that in interval notation. And we could also write it by saying that x is an element of all real numbers. They both mean the same thing. All right, now we want to find out, well, what is the new function? What is f of g of x? F is the lead function, all right, so this is our lead function here. So we're going to put a box wherever we have an x. So we have 9 minus root, and we're going to put a box inside here. And then the g function is going to go inside the box. All right, now we're going to look at that, and we're going to decide, again, what is the domain of this function? Is there anything that could cause a problem? Well, we know that we can't get a negative under the radical. That's going to give us an imaginary number. So is it possible to get a negative? Well, x squared, right? X squared is never going to give us a negative number, and we're adding 4. So we can never get a negative. We couldn't even get a 0. We can only get positive numbers out of what's inside the radical. So we're really okay. X can be any value, and it's not going to give us a negative under the radical. So the domain of the composite function is also all real numbers. Right? And since both of them have a domain of all real numbers, we know that the overlap would just be all real numbers. So our final solution for this is the domain of f of g of x is all real numbers. Okay, let's take a look at example 5. We need to first find the domain of the inner function. The inner function in this case is going to be g of x. And again, we want to look at g of x and decide, is there anything that would cause a problem? If I put a negative number in there, not going to cause a problem. If I put a 0 in there, not going to cause a problem, or a positive number. So any number is acceptable value for x. So our domain for g of x is going to be all real numbers. All right, next part, we want to find out what the composite function is and the domain of the composite function. Inside the box is going to go the g function. Okay, and again, we want to look at this function and decide what the domain of this function is. Well, is there anything that would cause a problem? Well, because we have this x squared plus 3x plus 2 in the denominator, we know we're not allowed to have a 0 in the denominator. So we want to decide what values of x could cause us to have a 0 in the denominator. So what do we have to do to figure that out? Well, we have to factor what's in the denominator, set it equal to 0, and see what values would make this equal to 0. Well, if we factor this, we get x plus 2 and x plus 1. It means when x is negative 2 or when x is negative 1, we would have a 0 in the denominator. So the domain is going to be all real numbers except negative 1 and negative 2. All right, and we're just going to keep this really simple. We're just going to write that x cannot equal negative 2 and negative 1. We're not going to put that in interval notation right now. All right, so we just need to see the overlap. So we have either all real numbers overlapping with x does not equal negative 2 or negative 1. So the overlap for this one would be where x does not equal negative 1 and negative 2. All right, so you have some practice here. I would suggest pausing the video, trying the practice, and then come back and checking your work. Distribute the 2. We're going to get negative 2x plus 5. Okay, letter B. This time we want g of f of x. G is the lead function. Put a box wherever we have x in the G function. Inside the box is going to go the f function. We distribute. Negative 2x minus 2 is our solution for that. Now, we already know that f of g of x, let's just write this down, f of g of x is equal to negative 2x plus 5. And now for letter C, we're being asked to put negative 3 in for x. So we're going to replace x with negative 3 in the f of g of x function. So in that case, we're going to get 11. For letter D, we want g of f of 0. So we need to write out g of f of x, which we've already found. And we know that that's negative 2x minus 2. And we want g of f of 0. So we're going to replace x with 0 everywhere in the function. And that'll give us negative 2. Okay, moving on. Move on to letter B. We want g of f of x. G is our lead function. Put a box wherever we have an x. Put the f function inside the box. Be careful when you distribute here. Negative 2 squared is going to give us 4. And x squared is just x squared. So final answer for that one is 1 plus 4x squared. Okay, letter C, we want f of g of 2. So let's write f of g of x first. We want to find f of g of 2. Replace x with 2. Okay, part D. Ooh, we want f of negative 1. So I'm going to find f of x first. All right, so our lead function is f. Put a box wherever we have an x. And the inside function is also going to be f. So inside the box goes the f function. It's a little sneaky, that one. Nobody likes those. So that gives us 4x. Then f of negative 1. Now we're going to replace x. So here's our function. We got 4x. So we're going to place x with negative 1. And we get negative 4. Okay, moving on to number 3. We have f of g of x. F is our lead. Inside the box goes the g function. Okay, we have 3 minus, now be really, really careful here. This is 2x plus 4 times 2x plus 4. We have to FOIL that. Now we'll distribute the negative. That's 3 minus 4x squared minus 16x minus 16. Final answer on that one would be, I'm going to put it in standard form, negative 4x squared minus 16x minus 13. Well, that was a little tricky, that one. All right, let's go on to letter B. All right, g of f of x. G is our lead function. Put a box wherever we have x. Inside the box goes the inner function, which is in this case f. Okay, distribute the 2. You get 6 minus 2x squared plus 4. Final answer here would be minus 2x squared plus 10. Okay, we want g of 1/2 for letter C. So for letter C, I'm first going to find g of x. Okay, so g is my outer function and my inner function. So inside is going to be 2x plus 4. So that's going to give us 4x plus 8 plus 4, which is 4x plus 12. Okay, so g of 1/2 inside 4x plus 12, I'm going to replace the x with 1/2. So we're going to get 4 times 1/2 plus 12. That's going to give us 14 for letter C. Okay, and then last one, moving on to letter D. Not quite enough room here. Let's see. We want f of x first. Our lead function is f. Okay, leave a box. The inside function is also f. That's 3 minus x squared. Okay, at this point, I'm going to put in my negative 1/2. Final answer here is going to be negative 73 over 16. Okay, last one, moving on to number 4. G of x is our first one. Okay, 25x minus 42. Letter B. We're going to do f of g of 1. Okay, the f function is the lead function. Put a box. Inside the box goes the g function, but when I write the g function, I'm just going to replace the x with a 1. Simplify that. Square root of 8, or you could also write that as 2 root 2. The square root of 4 times 2 is 2 root 2. I would take either answer. Okay, moving on to letter C. G of f of 6. Okay, we're going to put the f function inside with the 6 replacing the x. Simplify that. The square root of 0 is just 0. 5 times 0 is 0. 0 minus 7 is negative 7. And the last one is f of 2. Put our lead function out there first. With a box. Inside the box goes f again, but we're also going to replace x with 2. Well, that looks really intimidating. Let's just break that down slowly here. We get 6 minus root 4, which gives us 6 minus 2, which gives us root 4, which equals 2. Okay, moving on to number 5. We're doing letter I first. Remember that you have to FOIL 3 minus x. And if we put that in standard form, it's x squared minus 6x plus 10. And we're going to do g of f of x. I'm going to put it in standard form. Okay, that's double I. Find the values of x such that g of f of x equals f of x. Okay, that looks crazy, right? But let's just break it down. First of all, what did we find is g of f of x? And IB likes to use problem solutions from, the parts that were previous. So we know that g of f of x, this part right here, is what we've identified as negative x squared plus 2. And we know already that given in the problem that f of x is x squared plus 1. So we're just going to solve this for x. I'm going to subtract x squared from both sides, and I'm going to subtract 1 from both sides. The square root of both sides. So we're going to get x equals plus or minus root 1/2. And we know that root 1 is equal to 1, so you could also write this as plus or minus 1 over root 2. You do not have to worry about rationalizing the denominator. So either of those would be perfectly good solutions for me. Moving on to number 6, find g of f of x and state its domain. Remember, there are 3 parts to this. First, we need to know what the domain of the inner function is. Well, the domain of g of x, in this case, we could put any value into g of x. We could put a negative, we could put a 0, we could put a positive number, not going to cause a problem. So the domain of g of x is all real numbers. Okay, then we have to find f of g of x and find its domain. We have to decide, is there anything we could put in for x that would cause under that radical to be negative? And since x is squared, we're never going to get a negative. So the domain of f of g of x is also all real numbers. So the overlap between the inner function and the composite function is all real numbers. So the last part, the domain then of f of g of x is all real numbers. And just so you know, IB does like to write the set of all real numbers as x is an element of all real numbers. So you'll see that a lot in the IB world. Okay, let's take a look at part B, g of f of 4. Inner function is going to be the f function, and we're going to replace x with 4. Okay, let's simplify that. So we get 7 squared plus 4. 49 plus 4, that's 53. Okay, again, we have this composite function and the domain. So this is a little tricky, all right? We want to know, number 1, what is the domain of the inner function? So what is the domain of f of x? Is there anything that can cause a problem in f of x, right? Well, we have the square root of x. We can't have a negative under that radical. So the domain of f of x is going to be where x is greater than or equal to 0. If we were putting that in interval notation, we would say it could be 0 to infinity, including 0. Okay, that's the domain of f of x. All right, now step 2, we need to know what is the composite function and the domain of the composite function. So what does f of x look like? All right, well, f of x, let's see here. This was our box is under the radical, and inside the radical is the f function again, 9 minus root x. Okay, so what we're seeing here then is what is under the radical. Let me write this out a little without that box. 9 minus root x. Okay, so inside this radical here, this value has to be greater than or equal to 0. So let's just set up an inequality where we say that so we could try to figure this out. So 9 minus So 9 minus root x has to be greater than or equal to 0, right? So we end up with 9 is greater than or equal to root x. And I'm going to square both sides, so I'm going to get 81 is greater than or equal to x, right? Square both sides to undo that square root. And I'm just going to rewrite that with the x first, so that means that x has to be less than or equal to 81. All right, whoa, that's a lot. All right, so the domain of the composite function is saying that, x has to be less than or equal to 81. So we have to know what the overlap is. So let's do a number line on this one. So to find our domain for part of this, the domain of the inner function is going to be, let's see, x is greater than or equal to 0. And let's see, in blue, I'll do the domain of the composite function. The domain of the composite function says that it has to be less than or equal to 81. Well, where do they overlap? They overlap right here. All right, so the answer to this one then, the domain of the composite function, the domain of f of x is going to be between 0 and 81. So greater than or equal to 0 and less than or equal to 81. That was probably one of the toughest problems that we would do all year. You may need to pause the video, rewind, and watch that again. That was a pretty tricky problem. All right, moving on to our last page here. Okay, our lead function is f. We're replacing x with the g function. We're going to distribute the 2. Final answer, negative 6x minus 9. All right, then it says, hence, solve f of g of x equals f of x plus 3. Okay, so we know that f of g of x, right, that's what this is, these mean the same thing, is negative 6x minus 9. And if we put x plus 3 into the f function, let's just do a little side note here. What does that look like? F of x plus 3. That means in the f function, I am replacing x with x plus 3. So here's my f function. I'm replacing x with x plus 3. So that's going to give us 1 minus 2x minus 6, which is going to give us negative 2x minus 5. All right, so negative 2x minus 5, and now it just becomes a simple algebra problem. Solve it for x. Ooh, they have you working hard, IB. Okay, find f of g of x. Make sure that you use FOIL and distribute the negative and add like terms. All right, moving on to double I. I'm going to put that in standard form. This makes me feel better. And that's our final answer for double I. Part B, find the values of x such that f of g of x equals 3 times g of f of x. And of course, we're using what we found in part A. So f of g of x. F of g of x is right here. That's what we found in letter I. So let's write that. Negative 9x squared plus 1 equals 3 times g of f of x. G of f of x is what we found to be right here. Let's write that out. And then it just becomes back to, your favorite, algebra. Solve it, and you should get a single value for x. Right there, we can just add 9x squared to both sides. It goes away. We end up with 1 equals 18x plus 3. Subtract 3 from both sides. And then divide both sides by 18. We get negative 2/18 or negative 1/9 equals x. Okay, there was a lot to this video. Thanks for watching it to the end. Have a great day.